So now, всем привет. Меня зовут Matthias. And now I will continue in English. I'm sorry for that. But today I will talk about an open source project that I've been working on for, almost 2 to 3 years maybe. And it's called NUKE. And it's supposed to be the modern build automation for C# and .NET. So maybe first a little bit of background for that. I've been using MSBuild in the past already. I don't know, I probably started around 2012 at my first job. And, well, XML wasn't really handy to implement anything build related. But let me first ask maybe one question I forgot. Who's not familiar with what build automation is? Everyone is at least a bit, yeah? So generally, just to make a quick definition, it's everything that's needed to implement certain build steps, like compiling your solution, putting everything into artifacts, and by doing that, we eliminate the chance of human error. So MSBuild was one of the early things to do that in .NET, along probably with something like NAND, but they were all XML based. So then we were using PowerShell at my last company, and PowerShell suffers also from some issues, most of all from the unknown unknowns. So something you really don't know that you will have an issue with. For instance, PowerShell has a weird behavior for null comparison, for instance. It will also happily convert what you're supposed to be an array to a single item and stuff like that. So those were all, surprises, let's say. And it's difficult to adapt that since there are such unknown unknowns. It's complicated to adopt that into your company. I skipped Fake. Many of you have probably also heard about Fake. Who has used Fake? Maybe raise your hands. No one? Who doesn't know what Fake is? Okay, Fake is the name originates from the commonly known makefiles from the C++ world, and Fake is more or less synonym for make in F#, right? So F# is the host language for implementing Fake scripts. Why I skipped Fake? Well, mostly because I'm completely not fluent in F#. It would be something new for me, and also if you want to introduce that in your team, you're basically introducing a new requirement for every new developer that you may hire. They would need to know F# inside out, and well, that's not a good idea. Then I used Cake. Who has used Cake before? Okay, some more. Cool. So Cake, for all of you who don't know, is the make for C#, basically. Well, it's still scripting. It's still scripting approach. They do have extensions for VS Code and Visual Studio, also to make debugging work. But you really have to look things up on how debugging works. You have to install the extension. It's not something that you're initially familiar with if you look at it. And so, because you see there are those two AKE things, I thought, okay, let's subtitle this talk with 10 ingredients for an AKEless build system. And I have to give credit to Nikolai, who was mentioning that AKE pun at a presentation at the NDC Oslo conference. And today we will just dive into some of those ingredients. So the first ingredient is for NUKE. Why is it in a modern build system? It uses a console application for your build implementation. So this would be the first look at a very simple hello world, so to say, example in NUKE. You have right here at the top you have the main method for the console application entry point. What we do here is to mention the default target. So something, if you were about to invoke the build script, then you can either just call the build script or you pass the target that you want to execute along with it. But if we don't pass anything, it would be just word would be executed. And as you see, word depends on hello. So this is a common practice between targets, so certain build steps, that you can define dependencies between those build targets. And as you see, we don't have an actual implementation, so both execute delegates are empty, but as NUKE would properly print the headlines for each target, we would still end up with something like hello world. And there's a very important thing. First, compared to previous approaches, maybe also with other CI systems, a build written with NUKE just lives beside your usual code inside your repository. So it's committed along with the rest of the application. And the benefit of that is, compared if you have the configuration just on the CI server, let's say, you can even change that in a branch. Whereas if you have the configuration decoupled from the repository, then you would run into issues that the build wouldn't actually match the structure of your repository under certain circumstances. And moreover, the build project is part of your solution also. So it's an actual C# project, and as you see, it's marked here as being not built. So why is that? Because if this build project was about to compile the solution, then it would compile itself while being executed, right? So it would potentially result in access errors for replacing the assembly. So this is why this attribute is here by default. If you generate a new project from NUKE, this will check if the solution file has any active build configurations for NUKE. Okay. But I forgot, very important. As you see here, NUKE doesn't make use of any targets as strings. So there's no string here, right? Hello and word, they are both symbols. Anyone wants to take a guess what those symbols are? I mean, in terms of C# language constructs? Again? Properties, right. And do you also want to continue what the tail behind it means? Yeah, exactly. So, and maybe maybe I've missed that, but that first arrow is basically for having an expression-bodied property. Yeah, and the rest here, from the first underscore until the end, is just a delegate that gets returned. The major benefit here is that this will open up the possibility for a Fluent interface to define more metadata on the actual target. Also, this is refactoring safe. So if you invoke refactoring tools on hello, for instance, or world, then it would update the other usages as well. You can put, because it's just a console application, you can put a breakpoint anywhere where you like, and it would just work. Okay. Second ingredient, and we are zero-based, by the way. CLI tool support. So many of the built automation systems, they are required, because we just need them, to offer support for CLI tools. Something like MSBuild, for instance, or dotnet CLI, NUnit, XUnit, all those tools which you would potentially invoke for executing tests, for checking style guides, for pushing NuGet packages to NuGet.org or your private feed. And this is currently the the current state of NUKE, which tools it supports. The more major ones are much bigger, like dotnet, of course. And how does this look like? How does this support look like? So currently we're in one of those execute methods that I've shown earlier. And for instance, here we can, if we want to execute .NET as the command line tool and the command build, then we would call this method .NET build. So sometimes the first parameter is put together with the tool name to form an ultimate method, and you will see in a minute why. But first also you see code completion, yeah? Something that Cake or Fake would miss in certain IDEs. But now we can complete to .NET build, and something that's immediately noticeable is we have a summary which is the very same as the documentation on the website. So let's continue. Again, we're using some Lambda expressions. And now, if I want to set the project file which I want to execute .NET build on, I would first just type project file, and then I have a couple of possibilities here. We can either set the project file or reset the project file. And those, it's called the builder pattern. So you change some methods just to manipulate the original object. The original object is basically the S. And now we can just say, okay, set project file to the solution. We can continue to modify that invocation and say, okay, I also want to enable no restore, for instance. If I had executed .NET restore before, then I can just skip that. So let's do this, enable no restore. And you see, no restore is of type Boolean. I can either apply it or not. So this is why here I have not just set no restore and reset no restore, but also enable and disable, and also toggle. That's basically for composability. Okay, next is verbosity, and here's another example of the tool support. For defined sets of values that can be applied, you will get auto-completion as well. So in this case, you can choose from one of the actual meaningful values to be passed to the verbosity switch. All right, and also for set project file, if you're curious, and that exists for every tool actually. If you move your cursor onto the method, you can check what the documentation says. And again, this is the very same right here, the summary. It's the very same as on the .NET documentation from Microsoft. So how does this work? And I want to make this blank for a moment. Has anyone contributed to Fake or Cake, maybe? Yeah? Okay, so we have a little discussion at least. I guess if you would agree that if you want to add a certain tool, then you would implement that manually, right? So the idea with NUKE, in contrast, is that we are gathering metadata of CLI tools, because and this was actually the first idea how NUKE started. The idea of supporting command line tools is a defined problem, let's say. A command line tool has a bunch of arguments that you can pass. The arguments have a certain type, like they can be of Boolean, for instance, like there's no restore, or a project file would have a string, configuration is string. You could have lists which are concatenated with a separator, and that's what I did. I extracted certain metadata, and that's basically the way how we generate all the APIs for tooling support. Everything that I mentioned earlier too, of course. Here's one thing why this Fluent API can be of very great help. This publish test results property is a Boolean. And now we can fluently, with the .when method, say that only when this is enabled, we will set the logger and the results directory. So one other example for composition. Another example for composition, let's say you're creating a bunch of NuGet packages and you want to push them to NuGet.org or your private feed. And now for pushing or for sending data over internet, it might be useful to run them in parallel. Also, it never happened for me, but some people reported that sometimes you have connection errors and you need to actually rerun maybe the push target for pushing them to NuGet. But from the previous run, some packages have already been pushed. So you don't want to cancel that operation on the first package that would be sent as a duplicate. So here's how we solve that. Again, this first part is common for all the packages, but now on this line, we're combining that with all the NuGet packages that we can find in the output directory. And to actually create a set of multiple invocations, we also need to define the target path. And this will result in, depending on how many NuGet packages you have, X results, let's say. And we can also define the degree of parallelism. So in this case, I thought 5 might be a good idea. And also complete on failure means that on a failure, we just complete the whole bunch of invocations. This is how it looks on Bitrise, for instance. So there's the publish target, and I have a total of 4 packages. And you see the invocation, they're actually invoked as parallel, and only afterwards the output of every invocation is printed as it gets outputted from the actual command line. And also, this is also a bit different to Cake. For Cake, they don't lock the invocation by default. I think this is very important because this allows you to, if you run that locally, to just copy the command and paste it from anywhere. You don't have relative paths there, so you're safe to invoke it from any directory you're currently in. Okay, then there's also the possibility, because you don't want to use this Fluent API all the time. There's also the possibility to have a lightweight resolution. And for instance, a path executable would just try to resolve Git from the path environment variable. Local executable would be if you commit executables along in your repository. And package executable, I guess that's self-explanatory for NuGet packages. And it would just search the executable in that package right here. And how do you invoke that? String interpolation is a really great idea for that, because you can just put certain variables in between, and it works very nicely. Also, in this example, we don't see it, but all the Git calls, they allow to add additional arguments for working directory, for environment variables, for timeout. So everything that's common for the conventional way of calling process.start. It's basically just a wrapper for that. And one more thing, if you use one of those tasks for CLI tool support, for many of the ones that are based on NuGet packages, you have to explicitly mention them to be imported. Why not download them automatically? Because this could potentially violate the repeatability of builds. So in this case, we are just using package download. By the way, package download is a new feature from .NET Core 3. It's similar to package reference, but as far as I know, it's like an implicit exclude assets all. Yeah, because tools, we just want to have them there and invoke them, and in the end, there's just a version. All right, the next ingredient is path handling. Probably, if you have done anything with build automation before, you may have stumbled across incidents where you're passing a relative path and the tool just complains it can't do anything because the working directory is odd or something. What we do in NUKE is to provide absolute paths like all the time, every time it's possible. That's the default, basically. Root directory right here is a property that you get from the base class from which you inherit, and root directory is usually that directory where the .git folder is or .svn, so basically the root of your repository. And now, you see, I also mentioned it here, division operator magic. We're using the division operator to kind of mimic the path separator. And the major benefit here is that on Windows, we can, or depending on whether you're on Unix or Windows, we can just use / or / automatically, and you don't have to do anything for that. If you intentionally want to create a Unix or Windows relative paths, then you can do it with casting, and if you want to have a relative path, you could use that method to get the relative path to basically root, report, it's like root, source, report. This also ensures that you can easily refactor your code. So with writer, for instance, if you select an expression and you extract that, it will also offer you to replace all the other occurrences of that. So this is great for refactoring tools as well. And if you pass one of those absolute paths or relative paths, they get automatically converted to string. There's an implicit conversion, so you can pass them as string and don't need to do anything more about it. Third ingredient, value auto-injection. And that's something that I've noticed with many of the other build automation tools. They have some kind of setup targets for instance, parsing arguments from the command line, something that you put as an input into your build. For instance, you want to call your build and with the target blah 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 and configuration blah blah blah. They would have an initial target which resolves that. Or another example is Git version. Who's using Git version for producing? Yeah, Git version is basically a tool for producing semantic versions from your Git log automatically. So you just have to follow a certain workflow like Git flow or GitHub flow. There are several, and it would automatically generate a version identifier for you. That's another example for one of those initial targets work. And here's an example how this works in NUKE. Here we have a bunch of fields, basically, and we can attribute them with parameter. This will automatically allow us to pass the value from the command line. So for instance, for a simple string value, we can just say -- value hello. For an array, we can say -- array and then all the values. We can also define the separator here, but for the sake of simplicity, I will skip that. It supports numerous types of types. So Boolean, numeric values, arrays of them. Here's a nice catch. If we make it nullable, bool nullable, then of course if we don't pass it, it will be null. If I remove that question mark, it would be false by default. Yeah? And I can either pass the switch or not. And I could also pass the value false afterwards or true. So all those are supported. Configuration is not an actual enumeration, but it's some kind of class-like enumeration. The class-like enumerations have the benefit that you can just extend them. So this gets parsed as well. Oh, by the way, how it's parsed you can see down here. That's a target that got executed, and I'm printing just the name of the field along with its value. So we are right here, configuration. And now for absolute path, we can, or local path, we can also pass -- local path, changelog, and you see the actual value is the complete path to the changelog file. Solution works similar. Through this solution, I mean, it's a different attribute. It will automatically pass your solution, and you can access projects by calling get project, the name, and you can easily get the path of it. But for solution, just on its own, it will also print the absolute path. Git repository, the attribute would gather some data about from the Git folder, basically from the .git folder, along with the path, etc. And also, as I mentioned, Git version is also auto-initialized. And the major benefit here is all of those auto-injection attributes, they get executed right before any execution of other targets. So they are available whatever target you invoke, and you don't have to deal with any other stuff. One nice thing about those, why I said it's done before execution of any other target, is you can use those parameters, and let's say in this case API is a parameter, Slack webhook, etc. and configuration. You can define requirements for your targets in a Fluent way. And they get also checked prior to execution. So for instance, you see publish is dependent on clean, test, and pack. If I don't pass an API key, that will fail the build immediately. And not only if I invoke or if the publish target is executed. Also, if you pass some description with the attribute, you get them automatically included in the help text from your build. So those are the default ones down here, and those are the ones that are defined in my custom build. Okay, next thing is the target model. And something that everyone by now probably knows, we can define dependencies between targets. So compile depends on restore. I have either the option to call something like depends on restore, or I can make it the other way around. And on restore, I can say it's a dependent for compile. So it supports both ways. Why does it support both ways? Basically for extensibility. So sometimes if you have a base build class that you cannot really extend, you can still introduce targets as a dependency, but from the other way around. The same goes for scheduling dependencies. So in this case, restore must run. It should be must run after, so that's a typo. Restore must run after clean, but not every restore requires a clean to be executed. But only if they are executed together, then clean should be before. So in this case, you can say either before restore or the other way around after clean. Triggers is another example. If you want to invoke publish, for instance, you would maybe want to announce your published packages afterwards, but making a dependency from announce to publish the other way around, then you would need to invoke announce, and that sounds just weird if you're executing it from anywhere. So I decided triggers might be a good idea. So publish triggers announce, or the other way around, announce is triggered by publish. Those are all methods that you can call from the target initializer Fluent API. Another example. Oh, that was a bit too fast. Cleanup, for instance, must always run. It's somewhat like a disposable that is ensured to be executed, and then you would just say it's assured after failure, and it would always run even if some previous target has failed. Or announce must not stop execution, for instance, because it's basically meaningless for the outcome of a build. If it doesn't get announced, then so what? So in this case, you could express it should proceed after failure, just to swallow all the failures that it might introduce. Conditions, there are two ways of conditions. One is stacked statically before the execution of your build, and the others are checked immediately prior to execution of a target. Because sometimes a target might generate some files, let's say, for the following target, and in this case, of course, you would check them dynamically, whereas statically, there are different scenarios for statically. And the last one is skip behavior. So if you have a chain of dependencies, let's say, and you're actually skipping one of the last targets, then the question is, should the other dependencies execute or not? And this is how you define that. You can either say when skipped, then skip, or when skipped, then execute. Here's an example for a complete build graph, how this could look like. Let's start with the normal dependencies. So integration test is dependent on compile. I know basically you would point the arrow in the other direction, but that was JavaScript, so yeah, we just have to deal with it. So this is a normal dependency. Those dashed lines, they are ordering dependencies, so compile can be invoked just on its own, or it's scheduled after clean. This trigger behavior is with the yellow arrow, and yeah, so for test, for instance, would be a good example for this when skipped approach, where you would express, okay, when it's skipped, then of course also skip the dependencies. The next thing is CI integration. That's one of the more recent. I don't have water anyway. That's one of the more recent introductions, and it's very cool, I think, at least. If you run your build on a CI system, and in this case, this is GitHub Actions. Thank you so much. In this case, this is GitHub Actions. You see that the targets are automatically collapsed. So I will, for everyone who's short-sighted, as me, those are the targets, and they get automatically collapsed, and you can decide to expand them. This happens automatically. I mean, the build infrastructure will automatically turn those blocks into GitHub understandable blocks. So that's about the output. There's a second thing. Let's blank it for a moment. Who is using any CI system and maintains their YAML files manually? Okay, a few. Let me just take one zip. Okay, so the general issue here is if you're doing your implementation in a build system such as NUKE, potentially you would need to keep your YAML file updated. And I thought, okay, why not generate the YAML file or the settings file, whatever it is, from NUKE itself? I will use AppVeyor as an example right here. And if you want to build your NUKE build on AppVeyor, then the first thing you do is just put the AppVeyor attribute on your build. The next thing is you decide, okay, which images should it be built for? You can pick a bunch, so I picked only 2, but it's basically params of images. And you also tell the attribute which targets should be invoked. And that will automatically create the configuration files. Currently, TeamCity, GitHub Actions, Azure Pipelines, and AppVeyor are supported. And with every execution of NUKE, those configuration files get automatically updated. So even if you're, and that's a good example, even if you're renaming the test target, for instance, since we're using name off, that gets updated automatically. So we have those configuration files automatically generated. Now what? There's some more integration here. For instance, on CI systems, you usually want to publish artifacts through the web interface. For PAC, we would just need to call producers and pass along this, I never know how to properly call it, but you know, this wildcard matching, and there are some different names, but basically all the NUKE packages from the output directory. And just that definition is enough for AppWare to automatically get the NUKE packages published. No additional work is needed. So you see also some tests are published, so that's just from another target. Okay, that's about artifacts. The second is parameters. The stuff that we've already seen, like fields being attributed with parameter, in TeamCity you will automatically get this view, and you would see that API key, for instance, is required if we want to invoke publish. For configuration, we have an actual drop-down to choose from the allowed values. Slack webhook is required too. Source has a default value provided, so it's inserted there as well. And verbosity has a drop-down as well. Next thing, partitioning, and let's black it for a moment. Executing tests is a very great example when you actually, or most of the times, want to run tests in parallel, especially if you can run them on multiple agents. Locally, that's a different matter, but if you have several agents available, that's a common use case you want to take advantage of. How does this work in NUKE? We have the test target, and we can express that the test target should be partitioned. I feel like I should rename that to be partitioned, but anyway, and it's using the test partition. And for the test partition parameter, we are defining that it's a partition of 2. So a total of 2 partitions. And inside the implementation of that target, we have first all the test targets, which we can get, and then the relevant projects for the current partition. And so this works generically on any enumerable, basically, the get current, and will return just the relevant projects for the current partition. And down here, that's not so important, but let's see how this looks. This is generated, again, just for Azure pipelines, but generated also in the way of putting an attribute on it. And you see that test is automatically split into 2. They are jobs, I think, yeah. It's very difficult sometimes to remember which CI system calls jobs and tasks and stages and whatnot. So they are separate jobs. And also you see for Azure pipelines, it also creates several stages for all the images that I pass. And locally, you would have a partition of 1, basically. If you execute that locally, and you would get basically all test projects would be relevant projects. But this way, you can also easily, basically parallelize everything. This is how it looks in TeamCity. That's basically the collective test target, and it has dependencies for test 1 and 2 and compile. And you see the second partition only executes 1 test because I have currently just 2 test assemblies. All right, IDE extensions. Yeah, that's cool as well. So as I mentioned, most of the stuff just works out of the box. We don't have to install any extension necessarily. But of course, it's always good to have some more tooling. This is one that all the extensions have in common. So there are extensions for Writer, ReSharper, Visual Studio, VS Code, all the major IDEs basically, and editors. You have a snippet for writing a target more quickly, which is basically the end target live template or snippet, however you want to call it. That's the same for all of them. From VS Code, it looks like that. You can use the command palette to invoke NUKE, or you have those code lens items right above the target declaration. That's Visual Studio. you have a task runner, and all the targets are mentioned here. And on the left, you have two buttons to decide either you want to include or exclude dependencies, and you want to debug or not. It's very interesting, the implementation for Visual Studio, because it's not, you won't be able to automatically attach as that, I mean, from implementation-wise, but we are waiting for a file being created in the temp directory, and then we will attach to the process ID that's put into that file. And it's a bit weird because the Task Runner Explorer was not really easy to write. Okay, and in Rider, it looks like that. It's integrated in the Alt-Enter menu. So from anywhere in that target, you can just hit Alt-Enter and you can decide execute, debug or not, and dependencies or not. Also, you see right here, there's a run configuration. Rider has this, or the IntelliJ IDEA-based IDEs, they have the concept of run configurations where you can change arguments, working directory, environment variables, etc. And also, that's funny, that's from my notebook, you get automatically the NUKE sign on your touch bar. That was great. Okay, this is something we probably only can deliver in Rider. It's a live graph of your dependency diagram. So on the left-hand side, we're removing just this before call, and you see it gets re-rendered, and so here's the before arrow, and now when we remove that, then clean is not before restore anymore. It only has the normal dependency from publish. Okay, global tool. How much time do I have? 5 minutes? Okay, should be good. A global tool is available, and that's basically, yeah, you install it first like that. You don't need that on every developer's machine, but it's used for the setup. The setup is the first thing I'm going to show you. So you call in the repository of your choice, you call NUKE or just NUKE colon setup, and we'll ask some questions about how you want to name your repository, where should it be, which version do you want to use, so it offers you the local NuGet packages, the pre-release ones, and yeah, etc. And you can decide, do you want to put it into your solution or not? And there's also a more enhanced wizard, because it will generate a few things for you automatically at first. You might just delete that, but it's just to get people familiar with the idea. This is what's happening. So at least currently, we might get rid of that, but there's a .nuke file added as a marker for the root directory. It also contains the solution path if you choose one in the dialog before. Of course, the console application CS project file, a default build CS class, what I mentioned, 2 bootstrapping scripts, PS1 and SH, or bash scripts. They're responsible for, if it's not there, they will install the .NET SDK. But it also works with .NET Framework or Mono if you want. But I think there's no point in not using the build with the SDK. Even if you write your build script with the .NET SDK, you will be able to compile .NET Framework and Mono. I mean, that doesn't depend on each other. Editor config and .settings, they're for formatting. And your solution file might get changed if the project is added there. And then the global tool will also give you shell completion. So we have a bunch of targets right here. You see, I just type a few letters, hit tab, and it will complete. Also for verbosity, for instance, and it also knows about which values are valid for verbosity. Build sharing, I will just do that quickly. The naive approach is Git submodules, all right? NuGet packages is a naive approach too, but there are 2 others The first is external files. External files is basically the idea you have another file which just contains a URL. And the file at that position gets downloaded as part of the restore step from the build project. So it's there at the time when the build project gets compiled. That's the basic idea. .NET Global Tool is if you're writing a build, you could also potentially export it as a global tool, just like the NUKE global tool. And then you could install that on any of your fellow developers' machines and execute, let's say, just build. And it would be an executable that's available locally on your PC from anywhere. I have slides for that, but I will skip that. And also that might be interesting. Looking at C#8 default members for interfaces might be an interesting thing to look out for, because you can basically compose your whole build with several interfaces. I checked that it works, but Rider will only support default interface members from the next version, so I'm currently waiting for that. Okay, I will skip those two slides. And the last ingredient for that build tool, at least, is community. So many of the things that I've shown today were inspired from people from the community. So for instance, the Fluent way of when composing tool invocations, that part was inspired, for instance, from Nikita, who's maintaining the Avalonia UI project. They've adopted NUKE already. The build sharing options, they were an outcome of a discussion about, basically build sharing. And we thought, okay, what can we do? And there are countless other examples when community is really cool to get into discussions and try to find out new approaches on how to solve certain things. NUKE has a Slack workspace as well, so if you like it, it would be great to welcome you there. 2 minutes, I will finish earlier. And yeah, that's basically it. That's a summary slide with all the ingredients. Yesterday I thought that's a funny thing to make this presentation. But yeah, that was my presentation, and if you like, you can ask me anything you want. Thanks.
Has anybody questions?
Hi, my name is Anatoly. I want to ask you, shown that you have an CLI support, and the example was in shell, Unix shell, probably when there was auto-completion of parameters passed to the build script. Do you have the same for the PowerShell?
For PowerShell, that's also available, and also for Fish, which I don't use, but it was provided from someone who's contributing.
I see, thank you. And another question. I used in some cases in Cake, they have because it doesn't have kind of properties, they have string names for targets. That gave me the ability to generate targets in runtime. For instance, I have to perform a couple of checks, and I don't want to do them in the same target or the same task in their names, and so I just do for each. If you can add targets in a generative way, let's say, that should be possible. Yeah. Okay.
It's possible because we have. I didn't mention it today, but the CI configuration attributes, they take advantage of some event hooks. They get executed pre-logo, after logo, when on finished build. And that's basically the way how you can sneak into that, and you could probably add more targets for that. But I would probably suggest you to explain your case more in detail, maybe on Slack or something, because I feel like every time someone says, I want to do something automatically in a generation way, there might be a possibility to maybe make this more general, abstract, and usable to everyone. Yeah, that's easier most of the time.
I see. Thank you.
Okay, thanks, sir.
Hello, thank you for your speech. It was awesome. A very
Thanks.
simple question. Why did you call it NUKE? Just to make it AKEless, or there is something else?
Yeah, well, yeah, most of the egg names were busy already. I think there are a few puns out there about why it's called NUKE, because nuke everything else and whatnot, I don't know. But I think my general idea was like something like new make. Yeah.
Somebody raised hand.
More questions?
Who else?
By the way, about the CLI, I just want to add one more note, and then the other question. Currently, if anyone knows a lot about bash completion and such, there's one issue even for the .NET CLI. If you have this completion, you can't, it seems at least, can't have path completion in between, because the path completion is from the original bash. But if you have the .NET completion, you will lose that ability. So if anyone is interested, just ping me. That's an interesting issue. Okay, next question.
Yeah. Right. Okay. Question is, good system. It's really interesting that you can write your pipeline for CI with C#. Cool. But usually you have some system already established build.
You have some what? Sorry, can you speak a bit louder?
Yeah, I need to be closer to the microphone. Okay, sorry. So usually if you have already established some system for CI, the problem with adopting any system is to compare what would be the benefit of your approach comparing to the one you have already in the company. Yeah. Okay, so one of the benefits from your side could be, okay, you can write with C#, your native language, the pipeline for your build. Okay, good. Another question. Okay, at the moment we can see it's mostly about the non-visual way how you can execute. But for the big companies, usually the problem is, okay, how can I track visually what happens in my 10 agents, for instance, or I have a number of projects which are building in parallel, etc., etc. Yes. So the question: how do you integrate your system with the I saw the slides with the TeamCity, for instance, or with Azure or whatever. How I can run it and visually track the progress? Is that possible?
Of the targets that get executed?
Yes, of course. So maybe
okay,
some...
So one example was, let's go back, is this here. Is that not what you're asking for? The progress.
Yeah. So I don't really understand whether how this one is generated. So how I do integrate NUKE with some build server. So it generates those necessary YAML, whatever, and I pass it. I don't really understand the integration point here.
On Azure side, in this case, you would just define a new project and give it the Git repository URL, and then it would automatically pick up the YAML file. And I'm still not sure if that is what you're asking for. Yeah. Otherwise, just ping me afterwards. Okay. I can also maybe quickly, let's see, on TeamCity I can show you another thing. It looks roughly like this. Come on. So all the targets are here as well, and you can build chains. What is this? And this is a build chain as well. Just another look. Yes. The only thing on TeamCity side is defining the URL. That's all. It's magic.
I'm afraid we have to finish. We are running out of time. So let's thank Matthias again.
Дякую.